Hello everyone, this is Jude Leonard from Department of Physics, St. Joseph's College of Arts and Science, Kadalur. And here today we are going to discuss about crystal planes and Miller indices. As in the previous video, we already discussed what is crystal lattice. So lattice is a space where the atom is stored, and crystal planes are equally spaced parallelly planes where the lattice points are sequenced in a row, so it is called as lattice planes. Here it is a representation of a crystal plane, x, y, z coordinates, and the sides of the planes are indicated as A, B and C respectively. The basics of crystal planes. For understanding crystal planes, or we have to know coordinates of points, the points which represents the unit cell, and it is termed as A, B and C as we seen in the previous slide. And the next one is direction, and it's represented in a vector form. The projections are indicated as A, B and C, and this refers to the direction of the crystallographic planes. And there is a set of rules for representing crystallographic planes. It should not travel through the origin, and intersections are termed as A, B and C, and reciprocals should be taken, and it is referred as H, K and L values. The next one is Miller indices. It is a symbolic representation, that is vector representation of the atomic orientation, in which atoms are oriented in a particular direction, and the whole it is a plane, and there are a set of rules we can see in the next slide. By taking the reciprocals of the intercepts, we can refer as a crystallographic axis, and this is called as Miller indices. The next one is very important in terms of assigning the Miller indices, values of Miller indices. There is a set of algorithms are given over here. Following these algorithms, we have to find out the value of Miller indices. The first one is read of the intercepts of the plane. The intercepts of the axis x, y, z are termed as A, B and C. This is, we already discussed about it. And second one is taking reciprocals of the intercepts. It's important to take the intercepts value as reciprocals of the values. And the intercepts along x, y, z axis, and the values should be reciprocated. The next one is those values are reduced to the smallest integer values. The value should be reduced as a small integer values. And next one is the reduced values should be indicated within the parenthesis, as we already know that we should represent that as H, K and L values. And the last point is important. If suppose the plane is parallel to the axis, any of the axis, and the intercepts are 0, and we should assume that it meets at infinity. This is the example for indicating the Miller indices. By understanding this, we can easily interpret the Miller indices. This is an example. Here you can see a simple cubic. The first one is intercepts. The values are represented as A, B and C. Here you can see the A is exactly in the middle, that is 1/2 half of the x-axis, and B is exactly starts at the origin, and in C, that is the z-axis, it is 3/4. The intercept is 3/4 of it. The second one is taking reciprocals of it. That is the values of A is 1/2, and it is taking reciprocals of 1/2, 1/1 and 1 divided by 3/4. So we can get the values of 2, 1 and 4 by 3. So the third point is taking reducing the values to the smallest integer. Hence we have to denote the Miller indices in a whole number. We can convert that fraction into a whole number by reducing these values. So it is 6, 3 and 4. So when multiplying by 3 we can get 6, 3 and 4. So the values are 6, 3 and 4 respectively. So the next one is, there is an example for how to indicate the planes, the family of it. If it is 1, 0, 0, what could be the family of it? That particular crystal planes is 1, 0, 0 and 0, 1, 0 and 0, 0, 1. And here you can see there are a bar is on the top of that values. It means it is referred as a negative value, and it means that the projection is on the another side of the direction. If you view in a three-dimensional pattern, you can get a clear image of it. It means that the intercepts are in the other side of the axis. 1 bar 0 0, 0 1 bar 0 and 0 0 1 bar. These are the general principles for referring in the Miller indices. The first one is the Miller index is, if it is small, it means that it is more nearly parallel to the plane of the axis. The plane of the axis is nearly parallel to it. If the values are larger, means it is perpendicular to the plane of the axis. That particular axis should be perpendicular to the plane. And the third one is, we already told in the previous slide that the negative sign of the indices means at a point, the point at the same distance on the other side of the origin. The negative side, it is easy for you to imagine, to look into it in a three-dimensional pattern. Here is another example. You can see the representation of a plane 1, 1, 1. By looking at it, you can see a triangle shape of a projection inside a cube, and the intercepts are 1, 1 and 1 that starts from the origin. So this is the representation. Similarly, you can represent the Miller indices in the form of a diagram. So it is easy for you to understand the concept of Miller indices, the intercepts. This is the another examples for lattice planes. It is in the form of a cubic structure. There are three examples. The first one is the plane with 1, 0, 0. By looking at the diagram, you can easily understand it is represented in one dimension. It is, so the intercept is only in the one dimension, one direction. There is 1, so there are no intercepts in the other two, so it is 1, 0, 0. The next one is 1, 1, 0. Here you can see the intercepts are likely to be intercept in two dimension, two directions. So it is represented as 1, 1, 0. The last one is 1, 1, 1. So 1, 1, 1 means there is intercepts are all in the three directions. So you can easily see over there 1, 1, 1. And we already discussed the family of it. If it is a bar over there in the values, so the it is represented as taken as negative, and you can see the other side. 1 bar 0, 0 means the other side of the cube, and it is represented as 1 bar 0, 0. Similarly, we can take for the other two cubes. These are the another set of examples for understanding purpose. From left to right, you can see the first diagram. It is 0, 1, 0, and intercept is only in the y direction. The second one from left to right is, you can see a negative representation. So it is the cube is, the axis is represented, so it is in the another direction. So the representation is in the another direction, so it is termed as 0, 1 bar and 0. And the next one is, it is already we seen it only in the x-axis, 1, 0, 0. The next type is, so the representation in the z-axis, so no intercepts in x and y, it is termed as 0, 0 and 1. And the next one is, it is in the intercepts or in two direction, one only in is x and y, so no more intercepts in y direction, so it is 1, 1, 0. Similarly, you can see there are three types, and the representation of those Miller indices values, according to that the diagrams are given. This video gives some idea to draw or to indicate the Miller indices values. Thank you.